Hey, so welcome to lesson 5, part A. We're going to divide this into two parts because it's so important. The rest of the quarter, we have to know how to do all of these different skills that are crammed into this one lesson here. We're on page 71. So please turn to page 71. Make sure you're being authentic when you do this. I would not take shortcuts today. We're going to learn how to basically factor quadratic trinomials to solve them, and we're also going to learn how to solve them using square roots. To start off on page 71, there are 4 review problems. Should take you 1 or 2 minutes, right? Review these 4 problems and make sure you pause the video and actually review it. Remember, you want to multiply these all out. They all use the distributive property. Good luck. Pause the video. All right, so hopefully you did that for real. Here's what I got. Make sure that, this last one here, we have x plus 2 squared. That's not x squared plus 4. Come on, you know better than that by now, right? You got to multiply that out and then combine like terms. And these are the 4 answers I get. So that's a good review. Remember, we're going to factor later in this lesson, and factoring is working backwards. We're going to use the box method, which is something that we worked on the first week of school. But before we do that, we're going to learn how to solve these using square roots. A quadratic equation, if you remember, has an x squared. And the best way to get rid of an x squared is to just take a square root if you can. Sometimes you can, sometimes you can't. We're going to start, we're on page 72 now. All right, number 1a, we're going to look at this, which says solve each equation and state the property. We'll talk about the property, but we're going to solve this. We're going to use square roots whenever we don't have a middle term that has an x. Notice how neither of these have like an 8x or a 10x in the middle. It's just x squared with a bunch of numbers. This one's x plus 3 and it's squared and the rest of its numbers. This means we can just use square roots to solve it. Opposite operations. We're going to solve this just like Algebra 1. We're going to undo the operations. We're going to start in A by adding 9 to both sides. And when we do that, we're going to get 36 is equal to x squared. Now at this moment, we don't know if that x value was squared and it was negative before it was squared, or if it was positive, right? Because anytime you square a number, you get a positive. So we squared something and we got a positive 36. We didn't know if that was negative or positive before we squared it. Could have been negative 6, really. I mean, we're looking at this, we know it's 6, right? It's either 6 squared or negative 6 squared. But when we take a square root to solve some of these, all right, that square root will cancel the square. It's the opposite, right? So you square something, you square root it to go back. So we're going to get x equals, we cannot forget both of those solutions, the positive and the negative. So a quick way we write that is just plus or minus. And what it means is that x equals positive 6 or x equals negative 6. You have both answers and you have to write them both. If you don't, you're wrong. Okay, so let's look at B. Notice how we take x, we add 3, and then we square it. So if we're undoing this and using opposite operations, I would have to take a square root first. I have to undo that squared part. But again, we didn't know if the number was negative or positive when we squared it to get 121. So we have to include both values here. We're going to get x plus 3 is going to equal plus or minus the square root of 121. Well, I know the square root of 121 is 11. And this gives me this nice little equation here. I'm going to show you 2 different ways to do it. The first way, it's kind of like I did the other one. We're just going to write 2 equations. So we'll get x plus 3 is equal to 11, or x plus 3 is equal to negative 11. You have to write them both. We will subtract 3. This is Algebra 1, right? Probably like Math 7. We know how to solve this. Oh, that is an ugly 8. What happened? What happened to my 8? Please draw me a beautiful 8. Here we go. Oh, yeah, that's beautiful. But both sides, we're going to solve it. We get x equal to, what is this? Negative 14. So when I plug that negative 14 in and I add 3, I'm going to get negative 11. I square it. It's going to work out to positive 121. Same is true for 8. So both of those work. But I wanted to show you a little shorthand. Sometimes we do this. We write it like this. I'll use blue. X plus 3 equals plus or minus 11. So if I have that equation, then I can just subtract 3 just so like this. They will cancel. I will get x is equal to negative 3 plus or minus 11. Notice how I wrote that. Okay, well that means the same as this, but it's compacted, right? I put the plus and minus together. And at this point, I can kind of do it in my head. x equals -3 plus 11. Oh, that's 8, right? We should be able to do that in our head. And x equals -3 minus 11. That's -14. We don't care how you do it. Just do it one of the ways, but show what you're doing so that we can follow your logic. And that's A and B. So we're going to use similar strategies on C, and then you're going to use your own strategies here on D. You're going to do D. Ooh, do D. Anyways, C. We have 48. It equals 3 times the quantity squared. Let's get rid of that 3 first. That's the easiest way to deal with this. We can divide both sides by 3. And that'll give us 16 is equal to, these will cancel out. And we're left with x minus 1, and that quantity is squared. At this moment, we can take the square root, right? So we'll square root both sides. Don't forget to make this plus or minus, right? We just talked about that. So plus or minus 4, that's the square root of 16, is going to equal, these guys would cancel, right? Square root undoes the squared, and we get x minus 1. So if I add 1 to each side, and I'm going to use that method I just showed you. These will cancel. If I add 1, I'm going to get 1 plus or minus 4 is going to equal x. If you want to write 2 separate equations, you can. But I can do this math in my head. 1 plus 4 is 5. So 5 equals x. And 1 minus 4 is -3. -3 will equal x. Those are our 2 solutions. You can plug them in and check them if you have some time to do that. Right now, I want you to pause the video and do part D. As I said, here are the steps to do part D. First, add 18 to each side, then multiply each side by 2, then take your square root, then subtract 5. That should help you through it if you're not sure of the steps. So pause the video and do part D. Okay, here's what I get. I showed all those steps, right? So you first add 18, then you multiply by 2. That'll get rid of the half. And to get rid of that squared, we take a square root, right? And then don't forget your plus or minus. And I wrote it, you subtract 5 from each side, you'll get -5 plus or minus 6. So -5 plus 6 is 1, and -5 minus 6 is -11. Those are the 2 solutions to part D. Wow. Okay, so describe the strategy Oscar used to solve part A. This kind of takes us back to what we did the very first week. I can see what Oscar's trying to do here. What did he do? He subtracted 27 from each side, and he got x squared minus 36. And then Oscar is trying to factor this, and he did a great job because this does factor into this. And I'm going to take a little time right now to do a little review. If you remember what we did the first week of school, we moved everything over so it could equal 0 because we wanted to use the zero product property, which says that if you have thing 1 and thing 2, 2 factors being multiplied, and it equals 0, then each of them has to equal 0, or could equal 0, I should say. Each of them could equal 0, so we have to find each solution there. This is solving by factoring, but I wanted to take Oscar's example here of x squared minus 36 equal to 0, and I wanted to review how to factor this. If you remember how we did that, we do x squared plus 0x. There's no term in the middle, equals negative, or minus 36 equals 0. And then we used the box method when we reviewed. So the box method is pretty simple, but there are a couple steps you do have to know. The first term, which is x squared, will go in the first box. And then the second term, or the last term I should say, which is negative 36, that will go in the last box down here. Then we have to do the whole little x thing that we did. We need to multiply a times c, that goes in the bottom, and then we put b in the top. And again, the order that you put these really isn't important, but I need to find 2 numbers that multiply to a and c, but they add to b. All right, so I'm going to do that down here in green. A times c would be 1 times negative 36. That's a negative 36. And then b, remember there is no b, so we put a 0 up here. 2 numbers that multiply to negative 36 but add to 0, that would be negative 6 and positive 6. So these 2 numbers we're going to put in the 2 boxes here. The negative 6 will go here with an x, and the positive 6 will go up here with an x. Don't forget to add your x. And remember, it doesn't matter where each of these go in the box, but we're now going to use the GCF as we work our way left, and we're going to work our way up. We're going to pull out a GCF, and we're going to keep the sign of the box that's closest to the side. This does sound like a lot of steps. Holy moly. But here we go. So in the top, we have x squared and 6x. I can pull an x out of those. In the bottom, we have a negative 6x and a negative 36. I can pull a negative 6 out, right? And then as I work my way up, we have x squared and negative 6x. I can pull an x out. And then on the right-hand side, we have a positive 6x. So this will be a positive 6 over here that I can pull out of both. Remember, again, that it's always whatever the box is closest. We keep that sign. But we take these answers right here, x minus 6 and x plus 6. And that is our factored form here, x minus 6 and x plus 6. So if you notice what Oscar did way back over here, move the 27 over, we got x squared minus 36, and then eventually got x minus 6 and x plus 6. So that factoring right there, by the way, there's a classic example. You can refer back to it. But that factoring is going to be very important as we move on. Okay, Oscar used the addition property of equality to set the quadratic expression equal to 0 and then factor the quadratic expression. He then set the factors equal to 0. We remember how to do that, right? Solving by factoring. So I just gave you a nice review in how to do that. We need to move everything over to one side. We have to set it equal to 0 like they did right here, and then you have to factor it. Again, factoring it works because of the zero product property. The zero product property states that when the product of two or more factors equals 0, one of them has to be a 0. And in class, I call them thing 1 and thing 2, right? The two factors, you set them equal to 0 and you solve it. So why does the worked example begin? By adding 3 to both sides. Again, that zero product property is why we do that. We can't solve these without the zero product property, or we at least can't set them equal to 0 and solve it easily. So that is something we're going to focus on. Next, we're looking on page 74, right? We have Angela and Dwight here. Look at both of them. They both attempt to solve these, but they both mess it up a little bit. It says, what does each student do incorrectly? Go ahead, pause the video, and try to figure out what each one did incorrectly. Write it for number 2. Pause that video. All right, and so hopefully you found that neither student set it equal to 0, right? And that is an important step. You have to set it equal to 0. So I thought I would go about and solve Angela's and Dwight's. We do that together. So part 3 here, number 3 says solve each student's equation. So remember, let's set it equal to 0 first. We're going to subtract 7 from each side. We get x squared plus 6x minus 7 is going to equal 0. Ooh, that's an equal. All right, we'll do Angela's first. So as we work through that problem, remember, it's a times c on the bottom. That gives us a negative 7. And then in the top goes b, which is 6. You need two numbers that multiply to negative 7. You don't have a lot of choices, right? This is going to end up being 7 and negative 1. They need to add to 6, but multiply to negative 7. So let's use the box method. Remember, the first term goes in the first box, and the last term goes in the last box. First term here is x squared. We'll put that in the first box. The last term is negative 7. And then we take our two numbers that we found, we throw an x with them, and we put them in the remaining boxes. Remember, the order doesn't matter because it'll just switch the factors that we get on the side. So now we're looking for GCFs. Here we get an x, and then we get a 7. Working our way up, we'll get an x. And remember, it's always the sign of the closest box. So here we need a negative 1. So here are my two factors. We have an x with a positive 7. So this factors to x plus 7, and then x minus 1. All right, that is equal to 0. Now I can set each one equal to 0. So x plus 7 equals 0, or x minus 1 equals 0. And you should be able to solve this in your head, right? You get x equals negative 7 and x equals 1. So that is solving Angela's by using factoring. We can't use square roots, if you notice, because we have a 6x here. So if I go to take a square root, I got to take a square root of an x, and that ends up being very, very messy. Let's check out Dwight's. Dwight's looks a little weird because when we subtract 6 from each side, they will cancel, and I'll be left with x squared plus 5x. I'm just kind of moving this over a little. It'll cancel out. Will equal 0. I can factor this, but I don't need to do the box method because I can just pull out a GCF right now. We get x times what? X plus 5 is equal to 0. And now we can use the zero product property. I can say either x equals 0 or x plus 5 equals 0. And if x plus 5 equals 0, I know that x has to equal negative 5. So notice how this is a little bit easier because I can just pull out a GCF because those 6's canceled out. Okay, let's do some more factoring. We are still on page 75 here. Ooh, they just want you to fly through these, but I'm going to take my time a little bit and I'm going to work through it in detail. That way, all of you will have an excellent idea of how to solve this by factoring. So part A here, it's set equal to 0 already. I don't have to worry about that, but I'm going to start, I call it a diamond problem. It's A times C. We put a 12 in the bottom. I'm going to put the negative 8 in the top. I need to find two numbers that multiply to 12 but add to negative 8. That's going to be negative 2 and negative 6, right? Double check me, but that's the way it works. So now we're going to do the box method. Remember, it's the first term in the first box and the last term in the last box. And then our two numbers that we got from our diamond problem here with an X in each of the other boxes. Okay, so I'm going to pull out a GCF. In the top, we get an X. In the bottom, I get a negative 2. And then working my way up, I get an X, and then I get a negative 6. All right, so I get the two factors of X minus 2 and X minus 6. And when we did these the first week of school, remember I always said to check yourself before you wreck yourself. So I would just multiply that out to make sure I got X squared minus 8X plus 12. And I do. All right, but I can set each one of these equal to 0. So X minus 2 equals 0 or X minus 6 equals 0. I get the solutions of X equals 2 and X equals 6. Okay, so I think it's time for you to do one on your own. Let's do part B. Go ahead, pause the video and do part B all by yourself. Go. Okay, so here's what I got. I didn't have to do the box method because you know why? I'm looking at this and there's only two things that multiply to a positive 7 and give you an 8. I can do that in my head. So that's eventually where we want to be. We don't want to have to draw this box every time if we don't have to. But until you're pretty good at it, then you should probably do it. All right, part C. I want to do that with you because this one's a little weird. I want to teach you how to use fractions on the calculator, right? I look at this and I notice it's a GCF. I could pull out a fraction and I could pull out an X, but I'm just going to pull an X out for right now. So if I pull out an X as a GCF, when I factor this, I'm going to be left with 2/3 X minus 5/6. And notice how I pulled that out. Now I can still use the zero product property. X times 2/3 X minus 5/6 has to equal 0. So that means that either X equals 0, that's easy, right? Or 2/3 X minus 5/6 equals 0. So now is a great time to use our calculator. Let's add 5/6 to each side. 5/6, draw the line. These will cancel. 2/3 X equals 5/6. You know, our calculators are great tools, and we should know how to use them fully. And if I were to solve this equation, I would just divide both sides by 2/3, right? So I want to make sure that I do that in the calculator properly. So I want to take 5/3. We're going to use parentheses anytime we put a fraction in here. And I'm going to divide it by, right? I would divide both sides by 2/3. So I'm going to hit divided by, and I'm going to use parentheses again, 2/3. And when I do that, and I hit enter, I get the awesome answer of 1.25. Now, did you know you can just hit the math button and then hit enter, and it'll convert it to an improper fraction? You know, I kind of like the fractions better when we're doing this stuff. They give you numbers and fractions. We should probably give an answer as a fraction. Doesn't make sense to switch decimals, right? 5/4. So here's how that would look. You're going to make sure that your fractions, I write them. I put parentheses around them. We're going to divide both sides by 2/3. We got 5/4. So I'm just going to write X is going to be equal to 5/4. I'll put a little box around it so people can find it. These will cancel out, right? I'm trying to show what I'm doing. Whoa. But that's how we can use our calculator to help us with our fractions. Let's do part D right now. Can you factor this? Ready, set, go. Factor part D. Pause the video. Okay, false. That's what Dwight would say. This doesn't factor. So this is where Mr. Kelly is a little mean-spirited because I told you to factor that, right? Pause the video. Hope you didn't spend too long on it. But, I mean, what multiplies 12? 1 and 12, that can't give you a 10. And then what else? 2 and 6, that can't give you a 10. And 3 and 4, that can't give you a 10. So here's your life lesson. Not everything factors, right? So because it doesn't factor, we cannot solve it by factoring. We will have to use another method. This is Jim and Pam. And Pam's laughing at you if you try to factor that because she knows better, right? So how did they use different strategies in number 5 to solve this? And we're going to write this down too. But you can see that Jim, what did he do? He used square roots, right? He divided by 4 and then took a square root. Didn't forget the plus or minus, so that's cool for Jim. But Pam factored it using the zero product property. So we want to make sure we write that down. Jim using the properties of equality or opposite operations, and Pam using factoring with the zero product property. And that's it. That's where our focus is going to be today, just on these 2 methods. Next lesson, we'll learn 2 more methods. All right? Good luck to you all out there. Remember, it's nice to be important, but it's more important to be nice. See you.